The Titanic, hailed as unsinkable, glided through the North Atlantic, a marvel of human ambition. Then, out of the darkness, an iceberg appeared. A collision, a slow descent into the abyss. For over a century, we've blamed the iceberg for the disaster and the loss of 1,500 lives. But what if the real story is more complex? What if the iceberg was just the final trigger for a disaster set in motion long before? When explorers reached the wreck, they found not a single massive gash but a series of smaller breaches, evidence of a deeper flaw. The Titanic didn't tear open, it unraveled. The real mystery begins not at the moment of impact, but in the shipyards of Belfast, where the Titanic was forged. The ship's fate was sealed by the smallest components, millions of metal rivets binding its steel plates. These rivets, seemingly insignificant, were the ship's hidden Achilles heel. The disaster's roots lay in the chemistry of the metal itself. Why did the ship break apart the way it did? What made it seem so vulnerable? The answer is a tale of compromise, economic pressure, and misunderstood material science. The iceberg was the trigger, but the gun was already loaded. To understand what really happened, we must become forensic detectives, examining the Titanic's secrets at the microscopic level. The early 1900s were an era of technological rivalry and ambition. The White Star Line set out to build the largest, most luxurious ocean liner, the Titanic. At Harland and Wolff shipyard, thousands labored to assemble this floating city. Massive steel plates were fastened together by riveting, a brutal, fiery process. 3 million rivets held the hull together, each a critical point of strength. But the race to launch the ship quickly and cheaply led to compromises. While the central hull used strong steel rivets, the bow and stern, too awkward for machines, were riveted by hand. Here, builders used wrought iron rivets, easier to hammer but weaker than steel. This decision, driven by cost and convenience, would have devastating consequences. A choice made in the shipyard would be tested in the freezing Atlantic. Imagine building a chain. Most links are strong, but a few at the ends are weaker. Under stress, the chain fails at its weakest points. The Titanic's hull was a chain of steel plates, its rivets the links. The use of wrought iron rivets in the bow, the very spot that struck the iceberg, was a fateful compromise. It wasn't negligence, but a standard practice based on the knowledge of the time. Yet, metallurgical analysis of recovered rivets revealed a problem. Many contained high concentrations of slag, a brittle impurity. Some rivets had up to 3 times the acceptable amount, making them prone to fracture. The pressure to finish the Titanic and her sister ship forced the shipyard to source rivets from multiple forges, sacrificing quality. The result, thousands of weak rivets installed in the ship's most vulnerable areas. The weakest links were forged by the thousands, right where disaster would strike. The Titanic's fate was sealed by a hidden flaw, hammered into place long before the iceberg appeared. To understand the rivet's failure, we turn to materials science. Metals like iron and steel are ductile at room temperature. They bend before breaking, but in freezing temperatures, they become brittle. The North Atlantic was below freezing the night Titanic sank. The ship's steel plates grew less ductile, but the real problem was the wrought iron rivets. With high slag content, these rivets became glass-like in the cold. When struck by the iceberg, cracks raced through the slag-filled iron, snapping rivet heads off instantly. The shank was pushed out, breaking the bond between steel plates. In contrast, the steel rivets amidships were far stronger and more resilient. Had the bow used steel rivets, the seams might have held, limiting the flooding. A minor detail, the choice of rivet, became the difference between a damaged ship and a sinking one. The Titanic's greatest vulnerability was hidden in plain sight. Rewind to the collision. The Titanic grazes the iceberg, which grinds along the starboard bow. The force isn't enough to rip through the steel plates, but it hammers the rivets. The brittle iron rivets snap one after another. Imagine a zipper break a few teeth at the bottom, and the whole thing unzips. The hull seams failed in a chain reaction, opening the ship to the sea. Water flooded 6 compartments, far more than the ship was designed to survive. The designers planned for 2, maybe 4, flooded compartments, not 6. The sequential failure of rivets unzipped the hull for nearly 300 feet. The weight of water pulled the bow down, spilling water over bulkheads. The ship's safety systems were overwhelmed. The Titanic sank in less than 3 hours, undone by a flaw no one had imagined. The sound of popping rivets was the ship's death knell. The disaster unfolded in minutes, the result of a hidden weakness exposed by ice. Technical flaws alone rarely cause such disasters. Human error is always a partner. The Titanic was a product of supreme confidence, marketed as unsinkable, believed to be invincible. This overconfidence led to fatal decisions, too few lifeboats, slow response, and disbelief in the face of danger. The ship carried lifeboats for barely a third of those aboard, prioritizing aesthetics over safety. The crew, unprepared for disaster, delayed evacuation and launched lifeboats half-empty. The belief in the ship's strength blinded everyone to the reality. Technology gave a false sense of security. When it failed, no one was ready. Overconfidence, not just flawed rivets, doomed the Titanic. The Titanic's sinking wasn't caused by a single factor. It was the convergence of technical flaws and human hubris. The ship's steel structure inspired confidence, but its iron rivets hid a fatal weakness. The crew's belief in unsinkability led to poor preparation and slow response. The brittle rivets failed first, but overconfidence ensured there was no backup plan. The disaster was a chain reaction. Every link mattered. A decision in a Belfast office led directly to chaos on the Atlantic. The Titanic's tragedy was born from the friction between ambition and the unforgiving laws of nature. It's a lesson in the dangers of ignoring small flaws and overestimating our control. The Titanic's loss shocked the world and forced change. Inquiries led to new maritime safety laws, enough lifeboats for all, mandatory drills, and 24-hour radio watches. The International Ice Patrol was created, and no ship heeding its warnings has since been lost to ice. The tragedy's legacy is practical and profound. The story endures as a metaphor for technological overconfidence. The smallest details, like a rivet's chemistry, can bring down the grandest designs. The wreck, now a memorial, reminds us of our vulnerability. The Titanic's tears of rust are a slow surrender to the forces it was built to defy. The Titanic's story is a cosmic parable. We build complex systems and trust in their strength, but the universe is full of hidden icebergs. Disasters are rarely a single event, they're the sum of small flaws and ignored warnings. The Titanic's brittle rivets symbolize our tendency to overlook vulnerabilities. The real lesson is humility: question assumptions, seek hidden flaws, and remember that every chain is only as strong as its weakest link. Whether building ships or managing our planet, we must look for the small things that could bring us down. The Titanic's sinking is a minor event in the cosmos, but its lesson is universal. We are all voyagers in fragile vessels, sailing through an ocean of unknowns.